Hello students. So today we are going to continue this phasor diagram tool lecture. Okay. So as I had asked you that there is one more lecture I'm going to cover, and in that we will talk about, guys, what the phasor diagram of position versus velocity. So let's see, guys. First let's understand the concept of this, and then we can see some problems on this, and that would be done with the, guys, then we are done with the phasor diagram, and then we can move forward, guys. Okay, so if you see, guys, the thing is, if you see that if let's say if I write x is equal to what, guys, a sine omega t plus phi, so we know that, guys, v is going to be what? It is going to be a omega cos omega t plus phi. Okay, a omega cos omega t plus phi. So guys, if you see, in this case, if the, guys, if you see, this a omega cos omega t plus phi can also be written as what? A omega sine omega t plus, sorry guys, omega t plus phi plus pi by 2. Can we write or not? So guys, yes, of course we can write this thing. So it means, guys, if we compare this with this, guys, we can say that velocity is pi by 2 phase ahead from the position phasor, guys. Okay, means what does it mean, guys? It means when the axis will be going its positive extreme, okay, when it will be at positive extreme, guys, the velocity would be what? Going to its mean value, means the 0. Okay, means when it will be at its maximum, the velocity will be at 0. And guys, when it will be at mean position, this will be at what? Positive extreme. Something like this is going to happen, guys. What is going to happen? Let's try to understand. See, I'll show you first, and then we can make the phasor diagram, guys. So if you see, if I make a, guys, a particle, let's say, guys, let's say this is our particle, and this is its positive extreme, guys, and let's say this could be the negative extreme. So this is your amplitude. Okay, this is your amplitude. So guys, what we can say here, if I show you, if right now, if you see, guys, when the particle is at the mean position, the velocity is what, guys? Maximum. Okay, velocity is what? At its maximum. Means when your particle position is 0, velocity is at what, guys? Maximum. Guys, when your particle reaches to what? Positive extreme, guys, your velocity is what? 0. Okay, so guys, it means somewhere, if I draw a, guys, here, if you see, if I draw a, guys, this is a velocity oscillation. Okay, velocity oscillation I am drawing. Okay, so guys, what I will write, when, guys, at t equal to 0, at t equal to 0, it is here, the particle is what, guys? Here. At that moment, your uh, velocity is what, guys? Maximum, and it is at a what? Positive extreme. So guys, at this moment, what is going to happen? The velocity will be what, guys? If I assume this is an imaginary particle, it will be what, guys? Here at its maximum. Okay, it will be at what? Its maximum. And then, guys, when it will, your particle will reach here, guys, at positive extreme, it will be gone to, guys, what? Its mean position. Okay, so it will be gone to what, guys? Its mean position. I hope you're getting my point, guys, what I'm trying to say. And then, guys, when it will come back to its mean position, when it will come back to its what? Mean position, guys. Okay, then the velocity have gone to, guys, what? Velocity would have gone to its negative max velocity, means negative extreme, guys. Okay, and then when you go like this, guys, so if you see, you can see, guys, you can understand that velocity is ahead of what? Pi by 2 in terms of what? Phase. Means whatever the position equation is going to do, the same has, the same thing has been done by what, guys? By the velocity, like pi by 2 divided by omega time ego. Okay, so something like this way we can say. If I make a guys the phasor diagram, like not phasor diagram guys, if I draw the curve, okay, simply, so you can see that difference. Okay, we'll come to the phasor, but first I'll just show you guys what is the difference between these two. So guys, if I make this as a what, x also and velocity also guys, both I want to draw here only. So guys, if you see, if I draw the x versus t guys, so white is going to show guys what, x versus t graph, and guys then this green one guys, okay, it is going to show us v versus t graph. Okay, so if I draw now guys, if I draw now first x versus t, suppose guys, if the particle is starting from the mean position and going in the positive direction, so the curve will be what guys, simply something like this. Okay, if you see guys, I'll just make it something like this is going to be guys in this case. Okay, it is going to be something like in this case. So what is going to be guys, velocity versus t graph. So in that case, if I draw guys, if I draw, what is going to happen when the velocity is what, when the particle is at guys what, at its mean position, the velocity is going to be what guys, maximum, and it is going to start from here guys. Okay, it is going to start from here, and guys when it is at its positive extreme guys, velocity is going to be what, 0. And guys then if you see the curve, it would be what, it will start like this. Okay, it will start like this, and then guys it will go, if you see guys, it will go like this here. Okay, it will reach to its maximum here. Okay, and then it will go like this, and then guys it will go the peak here, and then something like this case. Okay, so this is the curve of what, v versus t. So you can see guys what it is going to do, what it is going to do guys, if I draw here. Okay, if you see guys, so if you see x versus t curve guys, it is, it is behind of what, this by what guys, pi by 2. It is what, behind of what guys, pi by 2. Can you see or not? Okay, so I hope you understood guys this thing. If you see guys, if I draw here, so you can see guys this lag is there. Okay, this lag is there. Okay, so I hope you understood this idea. Now I'm going to replicate this whole idea guys in the form of what, phasor now. So let's see. The thing is guys, if you see the size of the phasor, okay, the size of the phasor, size of phasor of position, size of the phasor of position guys, it is going to be what, a. Then size of the phasor of velocity is going to be what guys, a omega. Is this or not guys? Okay, because if you see at the leftmost side guys, what we are having the maximum value, that is what, a omega. So guys it is going to be what, a omega. Now if I draw guys, okay, if I draw, so what I will draw, I will draw like this guys. Let's say this is the green one, this is the position phasor guys. Okay, so this is, let's say guys, a. So right now this is your a guys, and right now let's say the particle is at what, at mean position, particle is at mean position. So guys your imaginary particle, okay, the imaginary particle that I want to draw, it will be what guys, it will be at here. I hope this is settled guys. Okay, so this will be your 1 minute guys, let me make this thing a bit clear. So guys if you see, yes, right now your phasor would be what, at this position, phasor would be what guys, at this position. This is the phasor that is going to what guys, this is the phasor that is going to what, move like this. Okay, this is the phasor that is going to move like this, and guys the shadow of the arrow or the point guys is going to locate the position of the particle. Okay, locate the position of the particle, and guys the size of the arrow is going to be what guys, a. Okay, settled. Okay, now guys if I uh, make the velocity phasor guys, so velocity phasor would be of size what guys, a omega. So let me is fix the position of this. So if I fix the position of this, guys, okay, it is going to be something like this. Okay, so I think now it's fine. So when, guys, your particle, imaginary particle, is going to be, guys, at this position, your velocity imaginary particle should be what, guys, at here. Okay, because then only it is, guys, pi by 2 ahead. I hope you're getting my point. And then only it will show the, guys, what, that it is at right now it's positive extreme. Okay, means the velocity is maximum and it is at what, its maximum positive value. Means I hope you're getting my point. Okay, so here, guys, what I can do, I can draw the velocity phasor. 1 minute, guys. I think like this way I want to draw. Okay, guys, this is your velocity phasor, guys, and this will be what, a omega. This will be what, guys, a omega. So in t time, guys, if we talk about in t time what is going to happen, so in t time, if you talk about, the particle will go somewhere here, guys. Okay, imaginary particle, and that would be what, shadow. So your particle has reached here, and guys, in the same very t time, your velocity phasor would have gone here, guys, and it will have what, this magnitude of velocity right now, guys. Okay, this is the magnitude of velocity it is going to have, that we can find out with this angle, because, guys, if this is omega into t, this is also going to be what, guys, omega into t, and this can give us what, guys, the magnitude of velocity, guys. Okay, if you see, I'll just show you, guys. This will give you what, the size of the position of the particle. This will give you what, guys, the position of the particle, and this will give you what, guys, the magnitude of velocity, and of course the direction of the velocity, guys, because it is in the positive side. It means velocity is right now what, guys, positive, and the particle is moving in the positive direction. Okay, I hope this is okay, guys. And as it will reach, guys, reach, this is going to reduce. Okay, and as it will reach here, guys, the particle will, the velocity will what, move here, means the velocity will be what, 0, and the particle is what, at its positive extreme. So I hope you understood the idea, guys. Now we will see a few questions on this, and then this idea will become what, more and more concrete in your mind. Okay, so let me take an example for you guys now. Okay, and we will solve this problem with the phasor only. So just for the thing, guys. Okay, so if you see, guys, the question is problem 1. Is problem 1. So the problem 1 is, guys, what it is, like this: a particle executing SHM, find position of the particle, find position of the particle, of the particle where its speed is, where its speed is 8 centimeter per second. Its speed is 8 centimeter per second if 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 maximum magnitude of velocity, magnitude of velocity maximum magnitude of velocity and maximum magnitude of acceleration, maximum magnitude of velocity and maximum magnitude of acceleration are 10 centimeter per second and 50 centimeter per second square, guys. 50 centimeter per second square. So, guys, this is given to us, and we have to find out, guys, what, that a particle is executing SHM, find the position of the particle where its speed is what, guys, 8 centimeter per second if maximum magnitude of velocity is what, and maximum magnitude of acceleration r guys what given, 10 centimeter per second and 50 centimeter per second. So guys, if you see, we know that. So let me solve this guys for you. So solution. So guys, if you see, the thing is, the omega into a is what guys, v max, and omega square a magnitude wise guys, okay, if you want you can put minus also, that is going to be what guys, your a max. So guys, from here we can find out what omega, that is very important thing because we need that. So guys, if you see, the omega into omega a is equal to what guys, a max. So guys, omega is equal to a max divided by what, v max. So 50 divided by 10 guys, and that is what, 5 radian per second guys, okay. So that is your omega. Now guys, let me make the velocity and position phasor, okay. So guys, if you see, the particle is executing SHM guys. Find the position guys, they had asked find the position, okay. So guys, see, the thing is, if I draw the phasor diagram, so guys, let's say this is your the position phasor diagram guys, okay, and this is going to be your what, the 1 minute guys, 1 minute, think it has gone some issue. Let me add few page. Yes, if I add like this, okay, yes. So guys, if you see, this is, let's say, the straight line guys, and on the x-axis it is going to do. So suppose guys, if your velocity, when the particle will be what guys, at the mean position, the velocity will be what, maximum, and that is going to be what guys, if this is a, this will be what, omega into a. So what do we need guys, we want that what it should be the position where its speed is what, 8 centimeter per second, the maximum is what guys, 10, okay. So guys, this is 10 given to you, and we want it should be what, the 8. So guys, of course, if I move this, okay, here, this will move here, okay. So guys, if it moves here, the projection of this is going to show is what, the magnitude of velocity. So guys, this we want how much, we want this should be 8, okay, 8 centimeter per second, and this is what guys, 10 centimeter per second. So we can find out the angle guys, that how much you have to travel. So if you see the angle guys, this angle would be how much, so sine theta, okay, this theta, this will be also what guys, theta. So sine theta is going to be, or cos theta guys, okay, cos theta, cos theta is going to be what guys, 8 by 10, which is what, which is 4 by 5, which means guys what, this is 37 degree, okay, this is what, 37 degree. Theta is what guys, 37 degree, it means theta should be what, 37 degree guys, okay. Now if you know the theta guys, you can find out the position of the particle, okay, you can find out the position of the particle, and this would be the what guys, position of the particle. And by symmetry guys, we can say here also the same thing would exist, okay. I have done only for the positive extreme because they have just asked the speed should be same. So guys, speed here and here is going to be what, same only, we know that. Now the symmetry is there in the left and right half. So guys, if you see, now I can find out the position guys, how, because guys, we know that theta is how much, 37 degree. So guys, if you see, this is the thing that we want, okay. So what we can write guys, we can write simply that sine 37, sine 37 is equal to x divided by what, the amplitude guys, amplitude is given how much, amplitude is given us guys, we have to calculate the amplitude. So guys, if you know omega, we guys know, and maximum velocity is given how much guys, 10. So divide by guys what, omega, we can get the a. So guys, let me calculate the a also. So a is what guys, a is nothing but what, v max divided by omega. So v max is 10, omega is what guys, 5. So this will be 2 centimeter. Okay, so guys, we can get this is 2 centimeter. So guys, sine 37 is what, it is 3 by 5 into 2 is equal to what guys, x centimeter. Okay, this will be what guys, 655 centimeter. So guys, whatever exists in the positive side, the same will exist guys what, in the negative side. So the positions possible where you will have the velocity as a 8, sorry, speed as a what guys, 8 centimeter per second is going to be what, plus minus 6 by 5 centimeter. Okay, plus minus 6 by 5 guys what, centimeter. So if you see, this is a guys question that we can solve with the phasor. Of course it is an easy question. If you solve with the algebra, maybe you can save a lot of time. But guys, this question I have just taken to show you that how do we use this method. Okay, how do we use this method. But now I'm going to take a very good problem, and then you will see the real application of this particular method guys. Okay, so let me take one more problem for you guys. So problem 2, problem 2, problem 2 is, okay, problem 2 for you. So guys, this question is literally a very good problem. Okay, so let me once speak, dictate this question, and then if you want, you can try this problem guys. So the question is two particles, again guys, two particles. Okay, so whenever the two particles comes, you should think about the phasor ones. Okay, so two particles are oscillating about origin, about origin, such that such that such that their positions their positions are are given as given as x1 is equal to 3a sine omega t, and x2 is what guys, it is equal to 4a sine omega t plus pi by 2. Okay guys, now what they are saying, calculate the maximum relative speed between the two particles, between the two particles two particles and also the time the time when it happens for the first time, for the first time. Okay guys, so if you want, you can pause the video here and you can try this problem by yourself. Otherwise guys, I'm going to solve this problem. Okay, so if you see the solution guys, okay, the solution of this particular problem. Okay, so let me add few pages here. Okay, so guys, let's see this particular problem solution. So guys, there are two particles and their amplitudes are also what guys, different. Okay, so we have to draw two two different uh, particles guys. Okay, two different particles. So guys, if I draw their velocity diagrams, okay, that also I can draw. And if you want guys that position diagram, that also you can draw. Okay, But right now what I feel is that because they are asking about the relative speed, it would be better to draw, guys, what directly the velocity phasor diagrams of both of them. Okay, we don't need to write, guys, we don't need to make the position phasor also along with the velocity phasor. Okay, so I am just going to, guys, calculate first the velocity phasor equations, and then we are going to draw the what, guys, velocity phasors. So guys, if we talk about v1, it is going to be what, 3a omega, guys, what, cos omega t. Okay, and v2 is going to be what, guys, it is going to be 4a omega. Okay, 4a omega cos omega t plus pi by 2. Okay, cos omega t plus pi by 2, guys. Okay, so velocity phasors are, guys, what, like this way, and the velocity phasor of second particle, guys, is ahead of what, the first one by a pi by 2 phase angle. Okay, so let me draw, guys. Okay, so if you see, guys, let's say this is the phasor, guys, and velocity phasor I am making, guys, and it is at its what, positive extreme, and this is what, guys, 3a omega. And now, guys, there is another one. This is what, this is with the 4a omega, guys, size. Okay, so let me make, guys, this a little bit like this. Okay, and this will be what, guys, this will be ahead of what, uh, pi by 2 angle compared to this. So guys, it means this is going to be, I'll take a different color, guys, for this. It is going to be here. Okay, it is going to be here. Okay, both we are assuming, guys, what, moving in the clockwise direction. So this would be the what, guys, your imaginary particles, let's say, if you want to take. Okay, these are the particles, guys, and their shadow will show you the what, velocity on this x-axis. Okay, on this x-axis it is going to show you what, guys, the velocity at this at any moment. So guys, if you see at t equal to 0, this is the picture. Now, guys, what do we need? We need the maximum velocity separation. Okay, we need the maximum velocity separation. So guys, if you see, what I want to show you again, the same thing, it is just similar like, guys, the idea that we had discussed about the what, maximum position. Okay, maximum relative position difference. Okay, similar to this, guys, here also. If I take at any time t, guys, what is going to happen? This would be somewhere here. So this would be the velocity, guys, this would be the velocity. Okay, and guys, let's say at the same very moment this has moved to here. Okay, this had moved to here, and this will be what, guys, your velocity. Okay, so guys, if you see, this is some positive velocity, some negative velocity. So guys, if I want to find out the relative speed, I have to add this and this, guys. Okay, so this will be what, guys, this will be your v relative. Okay, this is going to be what, guys, v relative. Now, guys, if you see, this v relative is nothing but what, if you see again, guys, something very beautiful is going to come out here. If you see, guys, this is nothing but what, if I make this line, so this rod, guys, okay, this rod shadow is only, guys, what is going to be what, your v relative. Can you see or not, guys? This rod, guys, shadow only is going to be what, guys, your v relative. Can you see? So guys, if I get the maximum shadow of this, guys, okay, then that will be what, guys, our maximum relative velocity. Means the length of this only, guys, is going to be what, your maximum relative velocity. Is this or not? So guys, if you see, it is very easy. Here only we can get, guys, if you see here, that this is what, this is 4a omega, this is 3a omega, guys. So both are what, guys, pi by 2 ahead, so angle between them will be what, pi by 2. So guys, this is a what, this is a right angle triangle only that is getting formed. Okay, this is a right angle triangle, guys, which is getting formed. So it means this will be what, guys, 5a omega. Is this or not? This will be what, guys, 5a omega. So it means, guys, what, the maximum relative velocity v relative max is what, guys, is going to be what, nothing but what, 5a omega. But they had asked that when the first time it is going to take place, guys. Okay, from t equal to 0, when the first time it is going to take place. Okay, so guys, to make it happen that when the first time it is going to take place, what I'm going to do, I'm going to show you something. Okay, so if you see, guys, I'm going to replicate the same idea here once again, so that I can show you what is going to happen at that moment. So guys, of course it means if we want that shadow should be maximum, this rod should be what, parallel to the x-axis. Okay, so guys, uh, that we have discussed there. So again guys, I'm just showing the same thing. If you see guys, we have to make the rod to be what guys, parallel to the x-axis, then only we are going to have what, the maximum. So guys, for to make it happen, what is going to happen guys, let's say this is your 3 omega, and this is what guys, this is your let's say something like this. Okay, let's let it reached here. uh, Let me remove this case. Okay, this I have to remove, and let's say please 1 minute. This is your position guys, and let's say this is the position of the second one guys, and now if I connect both of them, this would be what guys, the rod position. This would be the what is rod position that we want. So if this happens guys, this is the position. So if you see guys, if I show you this angle guys, this angle, this is going to be 90. Okay guys, this is going to be what, 90, and guys this is what, 3a omega. This is what, this is going to be your 5a omega, and this is going to be what guys, 4a omega. So guys, if this is a right angle triangle, we can say this angle will be what, 37 degree. So guys, if this is 37 degree, this will be also what, 37 degree. So guys, if this is 37 degree, this we can say that this is going to be what, 53 degree, very easily. Is this or not? By a very simple math. So guys, if this is 53 degree, we got the answer. The answer is what guys, that this rod, if you see guys, this this rod guys, okay, this rod has moved from here to here, and how much angle it has moved guys, 53 degree it has moved. Okay, so it means the time delta t will be guys, what it will be, the angle how much it has moved guys, 53 degree, converted into what guys, radian first. So pi by divide by 180 and divide by what guys, omega. So this will be the guys what, time for the first time when it is going to take place. So that's it guys. If you see, this question can be solved very elegantly with guys what, this phasor method diagram. Okay, so I hope you understood this velocity and position phasor also guys, and how do you use this particular method to solve such kind of problems. I wanted to take few more problems guys, okay, but I didn't like uh, like having time right now. So you can see in your modules or in your coaching notes or in the books whatever you are referring, you can see some problems, and you can approach those problems guys what, with this phasor method also. Okay, so in the next lecture guys, we are going to start discussing the energy analysis of a simple harmonic motion guys. Okay, so in the next lecture we are going to discuss the energy analysis of the SHMs. Okay, so thank you guys for today. I'll see you in the next class.